Imagine you're at a train station and you walk into the train station. It's supposed to be the most incredible train. The most futuristic train has all of the best bells and whistles. You paid for your ticket well in advance, but then whenever you get to the train tracks, there's no train tracks. The carts aren't connected. It's basically like everybody worked on their own individual cart, but did not think about how we're going to get all of these train carts to come together. So that's how technology is. Whenever we're designing, as we're going through, we have to always keep in mind how are we going to get all of this to connect together? To come from just an idea, just a vision, into true reality. So, first, I am going to talk about the past, and then we're going to talk about present challenges, and then we'll go into the future. First, UNET. Anybody remember UNET? No? A few people do. So, UNET was the foundation or the framework for cloud computing. So, without UNET, there would not be basically remote direct memory access or even InfiniNet. Sorry, y'all. So, in order for us to be able to continue to advance, we needed something on the infrastructure to even allow us to get to that point. So without UNET, there would be no cloud computing. So that is our past. Now let's take a look at our future. The physical bottleneck, cables. I don't know if y'all know, there are still old coax and copper, and some people are still using dial-up. With that, there's going to be challenges when it comes down to not just them people being able to have access to technology that requires high-speed network, but there will also be challenges with being able to get that technology advanced the way that we need to in all areas. There is also an issue with fiber. There is a fiber shortage, specifically fiber that is used for data centers. This means that in order for us to be able to upgrade the data centers or implement new data centers, it's going to take longer for us to be able to get to that point, which means we have to deal with the current infrastructure a little longer. So how are we going to be able to go through those challenges while we're still advancing? This is why we need an infrastructure engineer to be able to help to find ways to mitigate that until we're able to have access to the cable. Last, quantum. This is our future. Everybody talks about AI, but we still have to remember we're continuing to advance. We are building the future now. And in the future, it'll be quantum. As we are building the future, we have to remember not to forget security. With that, we need to ensure that the post-quantum cryptography is able to be applied from the physical layer to the application layer without having to compromise things such as performance. So we've taken a look at our past, at our present, and at our future. So now I want you to think to yourself, when you're looking at projects, when you're looking at where the technology industry is going, is the issue truly an infrastructure issue? And if so, you need to ensure that you have an infrastructure engineer to be there to help solve it. My name is Briana Faulk. You can scan the QR code to connect with me. Thank you all.